our sixth and final CSEC math exam preparation sessions. We would have started our journey from Tuesday, April 21st. And here we are at the end of this journey on May 7, 2026, sorry. We really want to welcome you all. We know that last session that we had on Tuesday, we had students from Edwin Allen High, Glenmuir High, Denby High. We had students from Eltham High, Yuaton High, really all around the country. And as you continue your preparation for your exam, which will be next Tuesday, that's Tuesday, May 12th, if my memory serves me right, because I'm getting younger as the days go. So we really want to let you know that we wish you all the very best, even though this evening is our final session in preparation for the math exam. You are free to go to our YouTube page, which is Region 7 Mathematics Team YouTube channel, and you're able to see all the sessions from April when we started to tonight or this evening. We start at 5:30. We are hoping to end at 7:30 p.m. tonight. Your mics, you pretty much have privileges to open your mic and speak with the presenter. Our presenter for this afternoon is Dr. Samuel McDaniel. He is filling in for Dr. Roxanne Francis. He is a senior lecturer at the University of the West Indies. That is the branch in Kingston Mona campus, and he's assigned to the Faculty of Science and Technology unit, specifically the Department of Math. So in the event you are thinking of attending the University of the West Indies, and you're even thinking of majoring in math, who knows? Maybe you will have the opportunity to meet Dr. McDaniel on a one-to-one basis. Now, remember, if you're unable to open your mics and speak with the presenter, you can share your responses in the chat, but our presenter would really prefer if you would open your mics. It's pretty much more interactive that way. So I will now hand over to our presenter for this evening, Dr. Samuel McDaniel. Over to you, sir. All the best.
Okay, I'm not sure if I'm muted or am I not muted.
You are not muted. We are hearing you clearly.
All right. Thanks, Mrs. Cami Johnson-Burrell for that nice introduction. And guys, everybody here, you can just call me Sam. Everybody calls me Sam, all right? So we're gonna go with Sam today. All right. If you want to call me Dr. Sam, that's fine, or Sam McDaniel, or Dr. McDaniel, it's fine by me as well. Anything you call me is fine. But Cami, I'm trying to share my screen, and somehow I'm not. My pen is not cooperating.
Is shared.
Yeah, but my pen is not cooperating with the before we started, I was able to get this thing going, and somehow I am not able to.
All right, so we'll just allow you to maybe close the app and maybe you can reshare.
Yeah, let me just close the PDF and then reopen it, and hopefully I'll be able to
Not a problem. So students, while we wait on sir to just close the app and he's going to reopen the app, we're going to ask, we currently have Amara. So I'm going down the register. We have Amara, Annalene, Janielle, Jaden, Asia. Lori, Mason, Samuel, Chantel, Sweden. I'm hoping I didn't forget anybody. Hopefully I didn't forget anybody. I'm just going to ask you to type the name of your school in the chat while we give our presenter a minute or two just to see how things are going on his side. So I'm waiting to see the names of your school so I can give a shout out to your school last session as well. So So let's see the fingers. So I'm seeing you, Edwin Allen. Any other school is present here? Only two schools? I don't think so. I'm sure other schools are here. Kingston Technical High, nice. Anybody else wants to share the name of your school? Vauxhall High, all right. Yes, I'm seeing more Edwin Allen. Any other student? So in the meantime, while you're doing that, we are now, sir is back on. Good to go, Dr. McDaniel?
I think so.
I'm seeing Demby High, Garvey Maceo High. Okay.
I'm just curious if we have any teachers around. That would be nice if we have one or two sitting in just to see what's going on. Do we have any teachers, Kami?
We normally have one. We normally have one. I'm not seeing her as yet.
Okay.
We normally have one, but I'm not seeing her as yet.
Okay.
So
No problem.
welcome to Edwin Allen, Garvey Maceo, Denby High, Vauxhall, Kingston Technical, Caron Hall High. And you can still type the name of your school in the chat. We're handing back over to Dr. McDaniel now, who is our presenter for this afternoon.
All
Dr.
right,
Sam?
thanks again, Kami. All right, so this is me. All right, so guys, welcome everybody in the group. I don't want to leave my screen, so I'm not gonna see I'm not gonna call you guys by name because I don't really want to leave this screen. But I'm just seeing a few names from my end, although I know that other persons are here. So welcome, guys. Good to have you. All the best in not just your mathematics exam, but also the other exams. And I want to big up Kami, Mrs. Johnson Burrell, for this intervention, which I think is excellent. I like the model as well, where we have guest persons speaking on different areas. Um, Today's session should be conducted by Dr. Roxanne Francis, and I'm here just basically filling her seat for her. So what I'm going to be doing, guys, is just to go through and have a conversation with you guys as it relates to the problems that were submitted to you from Mrs. Johnson Burrell. So you would have had the problems already. What I've done, I think what I've done is to retype them. Sorry, Kami, I had to retype them. That's a mistake. I may have OCD. So,
Fine, that's fine.
yeah, so I kind of retype them. And then we're going to be starting with January 2025. So I will allow you students to just check to see if you guys have this particular problem. The thing about measurements, guys, and this is one of the take-home message right away, get this out of the way. Whatever you see is usually correct, okay? Anything your brain tells you that is on the page, almost always you're correct. So you make sure you interpret what is on the page visually. And I can tell you one thing, almost 90% of the time you're going to be correct. So if you look at the page now without reading anything at all, and that diagram is there, I just want somebody to tell me what are you seeing? And I'm almost sure whatever you say is going to be correct. All right? So I'm just waiting for somebody to just open the microphone and just tell the others exactly what they're seeing. All right? Before we even start reading the problem. Yes, please, somebody volunteer. Remember, I don't have the names here, guys. So just open the microphone. Believe it, just open the microphone and start talking.
They know, Doc. They know, Dr. Sam. So students, anybody can open your microphone
And
and
just
talk.
just tell us what you're seeing. And whatever you say is going to be correct, more than likely.
There a sector.
Rihanna is seeing a sector, whatever that means.
With radius 18 centimeter
Whatever
from the
you see,
center
Rihanna,
point.
whatever you see is absolutely correct. Anything you see is correct. And that is usually the best start to a problem involving measurements. Okay, so now you're going to be working knowing that what you're seeing is a sector, Rihanna, as you said. All right, and you even went further to say that the radius is 18 and all those fancy things. But you see a little angle there, looks like X. You see something looking like a part of a circle, and we're going to be working this problem more than likely based on that. Okay, Rihanna?
Yes,
Can see?
sir.
Beautiful. So Rihanna, what I like to do, because I don't read very well, I like you guys to read for me. So Rihanna, I'm going to call on you just because you're on screen right now and just read what's on the page, what you're seeing. A piece of wire, 61 cm. Continue.
Long is bent to form a sector as shown in the figure below. The sector of the circle OPQ has center O and a radius of 18 centimeter.
Beautiful. So basically, what you have just read is exactly what you saw earlier. All right, which is pretty cool. So you just basically confirm that what you saw was what you saw, which is beautiful. Now, part one. Continue, Rihanna.
Show that the value of x is approximately 80 degrees.
Okay. So if we go back to the problem says that the piece of wire is 61 cm long. 61. All right. So 61 cm long. So you have to agree with me, guys. If you don't agree with me, let me know that when I add OP to OQ to the arc, I think this is called an arc, to the arc PQ, everybody should add up to 61. Now, we know that OP is the same as OQ, and OQ is 18. So, we know that this guy is 18 and this guy is 18. So the question is, what is the length of PQ? It's 3 marks. So we need to do a little bit of work, don't it? Nice. Now, if I add 18 to 18, I'm going to get 36. Now, the total is 61. And so the length of PQ got to be the difference between 61 and 18 plus 18. So let me see if I can write on the screen. So what we're saying here is that arc, if I can write, I hope you guys can see my handwriting. ARC, arc. Oops, sorry. I have issues here. I haven't done this for a long time, Kami. Arc PQ, all right, is going to be equal to, in terms of length, it's going to be 61. That's what we started off with. Minus, all right, what we already know, which is OP plus OQ. So it seems to me like it's going to be 61 minus, I think this is 36 in my memory serves me right. 18 plus 18 used to be 36. So,
25.
so 61 minus 36 is equal to, I'm going to get this. I'm
All
going to guess.
students help, sir. Oh,
Yeah,
Mariana
yeah.
in the chat is saying 25.
25,
Guys,
sir.
anybody else? So
Beautiful.
it's not Rihanna alone, sir, is talking to this evening. So anybody else can open their mics,
Yeah,
okay?
yes. And if I talk about, if I use Rihanna, Rihanna is representing you guys, all right? So don't feel bad if I don't call on another name, all right? But as Camille says, the microphone is always there for you to open and disagree with me and question me and argue with me and ask question. Why 18 plus 18, all right? So in this case, 18 plus 18 is because of OP plus OQ. And so the arc length, PQ, is going to be 20, I think I heard that 25 was said in the chat. So I'm going to use 25 cm, which is pretty cool. So now, and by the way, in an exam like this, in a question like this where it's valued 3 marks, everything you do is worth marks. So this itself is giving you some marks, all right? So you're not wasting your time to work this out, all right? Now, so this is now 25 cm, which is the length of the arc. Now, one of the things that we should know is the arc length there, PQ, arc length, so this is one I think you're going to believe in here with for sure, is that the arc length, if I can write properly, arc length is equal to, I want you to think of it as a fraction, F-R-A-C, a fraction of the circumference. Sorry guys, some bad handwriting. F-R-E-N-C. The truth is that I usually don't use, I think there might be an E missing somewhere. Circumference. The truth is that I usually use a different application to do this thing. So I'm really learning along the way in terms of how to use this thing. Now, so the circumference, as we know, and by the way, if you don't know, just make sure you check your cover of the book of the question booklet. I think the arc length, the circumference, I think is 2 pi r. I think most persons know that, either you know that or it's written. In fact, it's one of those things that you should maybe know. It's 2 pi r, which is the same thing as 2, which is the same thing as 2 times pi. I think we take times r, okay? So that's the area. They talk about foolishness, about area, foolishness. That's the circumference of the entire circle. Now what we're looking for is a fraction. And the fraction here becomes the angle over the total angle. And the total angle here is 360. Okay, so this is really key in this particular question, as I'm sure most of you guys will agree. All right. So it's going to be x over 360. I'm going to multiply this by this. Okay, guys? Nice. Now, with this in mind, the arc length, we did say it was 25. So 25 is now equal to x over 360. That's a fraction. Times 2 pi r. 2 times pi times r. All right? There's a lot of numbers going on here, but don't get too confused. Our job is to find what x is. Okay? So what we can now do is to use a calculator to work out 2 times pi times r. So I want somebody to work this out for me. Okay, it's more intuitive if you work this out for me. 2 times pi times r. And you tell me what you get. All right, so 25 is equal to x over 360 times, and I'm waiting for somebody to just confirm what this is, 2 times pi times r, which is the entire circumference of the circle. Anybody?
113.
113, Amara?
113.14.
113.14?
14.
Yes.
Beautiful.
1, yes, sir.
Nice, nice, nice. You're doing very well. Now, this guy is down here. What some persons may want to do is to just multiply both sides by 360. That works as well. If you multiply both sides by 360, the left-hand side becomes 25 times 360. It's just a matter of algebra now. Equals 3. Oops. It's not 3. It's 113.40. Oops. Point 0.14. I'm trying to see how to erase with this. You know, so I don't know how to erase Kami. Use this, I think, use this version of PDF. So I don't know how to erase. Unfortunately, I make mistake. Let me erase this. Which is
Maybe
equal
it's
to
okay. All right.
113.14, and we're going to multiply this by x. So if I rearrange now, I can divide both sides now by what is multiplying x.
Yes, sir.
And so x now becomes your final answer, and hopefully this is close to 80. And if this is close to 80, then we'd have gotten all 3 marks, okay? Then we're going to divide by 113.14. Now, I don't have a calculator with me. In fact, I have nothing with me today because you guys are going to be my little helper. And so you're going to tell me exactly what x turns out to be. 25 times 360. Then we're going to divide in by the 113.14. Hopefully, this is close to 80 because the question did say we are to show that it is close to 80. I think that's what the question says. Let me go back to the question.
Yes, sir.
It says show that the value of x is approximately 80. So if we, what did you get here? Anybody have any number for us?
Sir, for 25 times
9.5.
36, you get 9,000.
Everybody, man, that's why you do everything for me, Rihanna. Everything. And you divide by what?
Okay.
79.54.
So you get 79.5.
0.5
Sir, and when
Yes,
rounded,
sir.
sir, you get
Round
80.
it off, sir.
approximately. Approximately 80. You guys are awesome. Really, approximately 80. All right? Which is excellent. All right. So that is excellent. So let's go back now to the question because we're not going to just work out answers here. The idea is not so much the answer, is a process. So again, Rihanna read earlier that the length of the wire was 61 and we use it to form this figure. So everybody will add up to 61. And that's called the perimeter, by the way. So OP plus OQ plus the arc here gives us 61. We have 18 plus 18, that's 36. And so the difference here is 25. So the arc length is 25. And remember, we're going to think of the arc length as a fraction of the complete circle. And in this case, the fraction is going to be the angle over the total angle within a circle, which is x over 360. So once we have 25 now becomes the fraction x over 360 times 2 pi r. And so x works out to be equal to 25 times 360 divided by 113.14, which is about approximately 80 based on what the question asked. All right? Beautiful. Nice, nice, nice. All right. Any questions, guys? All good? If it's all good, you can just open the microphone and say, all good, sir.
All good, sir.
All good, sir. I love that. All good, sir. Nice, nice, nice. All good, sir. So there was another part. Now I'm going to ask Rihanna to read this part for me. Rihanna, calculate.
Calculate the area enclosed by the wire.
Oh, so the area enclosed by the wire. Very good. The area enclosed by the wire, as you can see there, is going to be what? A piece of the entire area. Again, it's just a fraction of the entire area, okay? And the fraction again will remain x over, ta-da, no problem. So this is a fraction, okay? Of, in this case, I think it's pi times r, or what they call pi r squared. So it's pi r squared. That's it. Now, the question asks us to say that we have to show that this is approximately 80. So I'm just going to use 80. All right, guys? Even though we know it's 79 point something, we can still use 80. And we'll get the full marks if we use 80. So we're going to get 80 over 360 times pi. We're going to take it to be 22 over 7 times r, which is 18. And we are squaring r, okay? So it's times 18 squared. And ta-da! This is the answer. Not so bad. Hello? Not so bad. Hello? Not so bad.
No, sir.
Not so bad, right?
Not so bad, sir. Not so bad.
Not so bad. Not so bad, all right? So it's a fraction. Just always remember, guys, it's a fraction we're looking for, okay? Because in this case, it's a sector. It's like a piece of a pizza, okay? A slice of pizza. So it's a fraction of 360 degrees. Always remember that. And remember what you see is exactly what it is, all right? So in this case, it's a slice. So it's a fraction of pi r squared. And I'm pretty sure somebody has this answer for me. I'm not too sure exactly what the answer is going to be. A lot of times, guys, just need to take your time. Make sure you use your calculator properly. All right. I'm not teaching you how to use a calculator tonight, but hopefully you're able to use a calculator One way of doing this is to multiply 80 times, this is just one way, 80 times 22 times 18 times 18, and then you're going to divide by 360 times 7. That's one way in which you can get the answer, okay? If you're going to use a calculator.
226.29.
226.29,
29.
And that's
okay.
Adonic. That's Adonic, Doc.
Adonai. I didn't see the name. Thank you very much. Oh, yeah, Adonic. Okay, thank you very much, Adonic. Awesome. All right. So, any questions before we move on? Should make sense. Should make sense so far. We're talking about area here, guys. So you have to think about area as 2 times pi. So, oops. Area as pi times r squared, okay? So that's area. Circumference was 2 pi r. Make sure you don't get them all mixed up, all right? Beautiful. Nice. So, I have no questions, so which means I'm going to scroll to my next. Look at part B. Part B is, all right, so I'm going to ask somebody to volunteer. Not Rihanna. I'm not going to say not Rihanna because I'm going to ask Rihanna to read. Rihanna, be on standby to read for me. But I want somebody else from Rihanna to tell me exactly what they are seeing. As I said before, whatever you see almost always is correct. So somebody just tell me what you see. Me see piece of cheese, but I want to know what you guys see. Somebody?
Sir, I see a slice of cheese too.
All right, that's what I see. I don't know. I just see piece of cheese. That's all me see when me see this picture. Thank you very much, Adonique. Everybody, look like one piece of cheese. All right.
I
Now,
see one slice of cheese cut from the cylinder like a pizza slice,
all
but from a
right.
cylinder.
That works as well. That works very well as well. If that's what you see, that's what you see, and that's correct as well. So, so what I think is Mariana. I'm not too sure if it is Mariana, but I think it's Mariana that spoke.
Yes, correct.
Right. So I agree with you, Mariana. That's what kind of see. Almost like you're stacking these 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 slices and they form and they stack them, stack them, stack them, stack them, stack them, stack them, stack them. You get this three-dimensional figure of height 8. So it's like having figure, the same figure we had before. You stack them, stack them, stack them, stack them, stack them, stack them, stack them until you get what? 8 cm. All right. Actually, it's a different figure. I just realized that actually different, completely different figure. But it kind of looked like the one we had before. So that's why I said that. All right. So we have this little slice on top, and it is stacked to 8 cm. This one, I think the radius looks like. Anybody want to tell me what the radius is? Hello?
I
Open
see
it up.
Lorna's mic on. Lorna, you can go ahead.
What's the
Sir, 12
radius?
centimeter.
What did you say, Lorna?
No, that was Shanali. Go ahead,
Shanali?
Shanali.
12 centimeter.
Awesome. And what is the height you're
8
seeing?
centimeter. Yes,
All
sir.
right. And in terms of the angular representation of the sector, what angle out of 360 are you seeing?
18 degrees.
18.
18. Beautiful. Now, we have not read the question yet, This is just what we are seeing. So let's read the question now. All right, let's read the question now. I did ask somebody to read the question for me, but the name is gone off the screen now, so I'm not even too sure exactly if she's here. So I want somebody to read a cylinder block of cheese. Continue. A cylinder block of cheese.
A cylinder block of cheese.
Has
Yeah,
a
go ahead.
radius of 12 centimeter and a height of 8 centimeter. The cheese is divided into equal slices. The uniform cross-section of a slice of the cheese is a sector whose angle is 18 degrees as shown in the diagram below.
Wow, beautiful reading, Mariana. It's not Mariana, it is Mariana. Yes, it is. Very good reading. Awesome. All right. So basically, I've just read what we just saw. Now, let us see what the question is going to be asking now. I'm pretty sure whatever the question is going to be asking, it's going to be based on what we are seeing on screen. So let's see what part 1 says. Now, Mariana, you can continue. Calculate.
Calculate the length of the arc AB.
Calculate the length of the arc A and B. Now, if you look, all right, at the top, just the top, forget about the depth. If you look at the top, then what you have there, as you can imagine, is nothing more than a piece of a circle. Okay? We have the radius, so we know the entire area. Sorry, we know the entire arc of the circle. The entire, I said arc, I meant the entire circumference of the circle. The entire circumference is going to be 2 pi r. Now we want a fraction of 2 pi r. I hope you guys agree with that. Because we want the length of the arc AB, so it's a fraction of 2 pi r. Everybody happy?
Yes, sir.
Beautiful. So we're making good progress. So what we're going to be doing now is to look and say, hey, I am looking for a fraction. A fraction, by now you realize it's 18 over 360 of, that of means multiply, of 2 pi r. And I think r here is 12. Ta-da! Now, whatever you work out here should be the answer. All right, so that's the arc length. ARC, arc length. And I'm hoping that somebody will take up their calculator and just tell me exactly what they get. One way of doing this, just telling you one way of doing it is to multiply.
3.77.
What do you get?
3.77.
3.77.
Yes.
Thank you so much, Amara. Awesome. And I'm getting the thumbs up from Kami as well. Sounds like you're all correct. Beautiful. 3.77. And it's arc length, so I'm assuming this is centimeters. All right. So that's the length of the arc AB. I want to go back to show you exactly what you just calculated. All right. So you have just calculated the length of this curved area here, AB. All right. We're not too sure exactly where the question is going, but we got this mark for sure. So now we're going to move on to the next part and see what the question is saying. All right. Now I need somebody to read what the question says. Given
that the area of OAB is 22.6 centimeters square, calculate the value of the entire block of cheese.
Oh, that's part 3. My bad. I think I missed out part 2. Didn't I miss part 2? Shanali,
Yes,
let me just
sir.
go back and see. I may have missed part 2. Oh, my bad.
So determine the area of the curved surface ABCD.
Thank you so much. I had missed that part. So this curved surface. Now, one of the things that may not be very clear, guys, is something that you may not know, is that if I have a curved surface here, and I have the same curved surface at the bottom, it's just one of those things that maybe was not taught to you, but now you can just take it from some, all right? So you have a curved surface here, and the curved surface right here. You can maybe trust me, all right? The area is going to be the length of the curved surface times the height, okay? It's like base times height, but this is not really a rectangle. But because it's the same curved surface at the top, the same curved surface at the bottom, we can always treat this, pretend that this is the length, and pretend that this is the height, and that will give you the answer, okay? So this is one of those marks that maybe would give you a little issue, but maybe if you were guessing, you would maybe guess it right anyway. Now, we did work out AB, and we know the height is going to be 8 centimeters. And that will allow us to find the area of this guy right here, okay? Again, is a curved length times the height. And the reason why we can use that formula, it doesn't always work, you know. We use the formula if the curved surface at the top is the same as the curved surface at the bottom, meaning that the figure is regular. So once you have a regular figure, you can use the curve length times the height and you'll get the area, okay? All right, so with that in mind, the area we're looking for, I'm gonna stay on this page. So the area is going to be, I don't remember what the number was, 3 point something, and I don't remember what the number was. But then we're going to multiply.
3.77.
What was it again?
3.77.
3.77. And then we're going to, and that's it, guys. It's as simple as this, okay? We multiply this by 8, and then we're going to get the answer, okay? And in that case, the area is going to be equal to, take your time. We're not rushing. Take your time.
30.16.
3.16.
Sir, excuse me, sir. You get 3.77.
It's not me. It was earlier. We did work out the length of the arc AB. You remember that we worked out the length of the arc AB? The length of the arc AB was just a piece of the entire circumference. So if you go all around, it's going to be 2 pi r. And we did the working before, boss. So we get 2 pi r. But what we're looking for is a fraction of 2 pi r, which is 18 over 360. Let me see if I can go back up and show you the calculation. See here, young boy?
Yes,
The
sir.
fraction, all right, times 2 pi r, all right? And we got 3.77. No problem, man. Good question. So now that we have the curved length, if we multiply by the height, you hardly see this in the classroom, I must say. Generally, the figure is usually like a rectangle or a square or whatever it is. So this is a little, lack of a better phrase, I'm going to call it a curveball. But I suspect you guys would maybe be able to guess that this is the way you'd work it out. It's a curve length times the height, which in this case is 30 point. I think somebody was saying 30 point.
30.16.
30.16. All right. In this case, it's area. So it's unit times unit, and unit times unit is going to give me unit squared. Okay. So, so it's going to be centimeters squared just because it is area. All right. Area. My handwriting is very bad today, but forgive me, guys. All right, beautiful. So what we just worked out was the area of this curved portion here. Nice. Nice. Then we're going to move on to part 3 if there are no other questions. Are there any questions? Are we good? You can open the
Yes,
microphone.
sir.
You're good. All right. Nice. Reminder, if you have any questions, make sure you ask them right now. Part 3. Shanali, you're going to read for me? I'm not too sure if you were the one who was reading, but just read for me. I think
Okay,
Rihanna is
sir.
giving me the thumbs up, which is good. Thanks,
Given
Rihanna.
that, start, sir.
Yes, given that.
Given that the area of OAB is 22.6 centimeters square, calculate the value of the entire block of cheese.
Whoa. Entire block of cheese. So what we could maybe do, you said area, you meant volume, right?
Yes, sir.
Calculate what? Read it aloud again. Calculate.
Calculate the volume of the entire block of cheese.
All right, don't move, Shanali. Let me tell you what happened with volume. Volume is generally, the formula for generally is base area times height. So if you know the base area and the height, then what will be able to give you volume, all right? Especially when the figure is regular. And in this case, we have a regular figure because the top look exactly like the bottom. If you look at the top, you get this little sector here. If you look at the bottom, you're going to get the same thing, and that tells you it is regular. And so the volume is going to be base area times height. So the volume of this piece of cheese, so volume of slice, S-L-I-C-E, I'm going to call it slice, is going to be equal to base area times, times height. Sorry for my bad handwriting. Now the base area here is 22.6. That's base area. The height is what? It's 8.
8.
So times 8. So this is just the volume of this slice, and you can work that out and tell me what it is. It's about 100 and something, I'm sure. I'm waiting.
Sir,
Sir,
180.8.
One what?
0.8. 80.8.
Sorry, the microphone just chipped out. I was like a 180.
Sir, 180.8.
180.8. And this is volume. So volume is length times length times length. And that tells you that the unit here is going to be cm times cm times cm, which is cm cube. Okay, just for the record. Now, this is not the volume of the entire block of cheese. This is the volume of this slice of cheese that we are seeing. Okay, so 18 degrees, all right, will give me 180.8. So the question is, what is 360 degrees going to give me? All right, let's call it unknown. Hello? I need a amen here. 18 degrees, give me a volume of 180.8. So the question is, the entire block will give me what? And the what is what the question is asking us to find. Hello? I need an amen.
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 All
Amen.
right. Good. With an amen now, a nice little trick, guys. I don't have a different color here because of the device I'm using. Unfortunately, I can't change my color because I'm not, I just can't change my color. So I'm going to just make a little fraction here, guys. A nice little tool. And I'm going to just tick right here, guys. So you're going to say 18 to this goes 360 to x. And you just form a little fraction. 18 over 360 equal 180.8 over x. Our job is to find x. So we're going to have 18 cross multiply
Sir,
x
you would
equal.
cross multiply to find the
Very good.
x.
Very good. I hope Kami is checking who is talking because I'm literally looking at my screen here and not too sure who is speaking, but that is excellent. All right, and therefore I can get x now as everybody on the right hand side. You don't need to use these calculators yet, and then we divide by 18, and at this stage you just take up your calculator and work this out. All right, and that should give you what the volume of the entire block of cheese is.
Sir, I
Anybody?
get 3,600.
3600, and this is cm cube. Okay, awesome. Ta-da. Now I want you guys to just clap yourselves. Okay, this is really, really good stuff. All right, so it was not too heavy once you understood what was going on. If you notice, what we did here was to find the volume of the block of cheese that is on the screen. We got that to be 180.8. So 18 degrees gives us that. So the question is, what does 360 degree gives? And we just form a nice little arrow diagram. I call this arrow diagram. I think Ajani may have used the word rule of three. That's right name, rule of three. But anyhow, the point is that we had 18 going to 180, 360 going to some unknown, and we were able to find x to be equal to 3600. And that is the final answer. Any questions?
Sir, for the answer you get after u times 180.8 times 360 divide
Yes,
by
sir.
18, I get 3,616
Yes,
And
sir. That is
CM, CM.
correct.
cube.
3,616?
16.
16.
All right, no problem, no problem. All right, so we'll work with that one. Beautiful. And that's the volume of the entire block of cheese, all right? Because the cheese was of height 8 cm, and we're going all the way around, all right? So understand what we just worked out. We worked out the volume, the volume of this, and then we scale it up to 360 degrees, and we got 3616. Awesome. Good job, guys. Nice, nice, nice. Any questions? No? All right. I'm going to no questions? We're good. All right, let's see. Look at this. This is another question. All right, so I'm gonna continue. As I always say, what you see is almost always correct. So I'm going to ask somebody, anybody, open the microphone and just tell me what you see on the screen. What does that diagram look like? You have to interpret what you see, guys, all right? So look at what you see first. Before you even start reading, tell me what you see on the screen. I'm not going to tell you what I see. I know what I'm seeing. But I want you to tell me what you see. Hello, somebody, anybody? Or you can say, I'm seeing something looking like, and that is good enough. And then we're going to see what the question is asking. Yes, Brianna? Not
I
Brianna,
see
my bad.
a
It's
half a
Brianna.
cylinder and a cuboid.
Go again, keep Brianna.
A half of a cylinder and a cuboid.
Miss Brand, that's exactly what I am seeing as well. I'm seeing this rectangular block on top of something that looks like, half cylinder. So I'm agreeing with you. So yes, awesome. And I think um, Mariana agrees as well, and that's what she's seeing as well. So, all right, so we see this. And remember, guys, remember a lot of the problems that you get with these guys rely on what you see. And what you see almost always is going to be correct. Because that's the way your eyes process it, all right? Almost. So the question now, they're going to ask questions, There are going to be questions now. But any question they ask now is going to be related to what you saw or what is on screen. And we can deal with it, all right? I'm pretty sure we can deal with it. So let us just change page and see exactly what the question is. Hello? Are we good? Should I change page? Yes? I want to hear a yes.
Yes, sir.
Yes, sir. All right. So Brianna said I'm to change page. Let's change page and see what it said. A. All right. So, and I need a reader, right? Calculate. Calculate.
The total surface area of the surface area of a closed cylinder is A equal to pi r square plus 2 pi r.
All right. So don't move around. Let me just explain what's going on here. They ask for the total area of the solid. This is a lot of work, by the way. The total, but it's 4 marks. So we get some marks for it. So we can spend some time on work. Though. Total surface area. All right. Now, so, all right. Surface area. So what we're going to do for the surface area, Rihanna and others, we're going to look surface area is only on the outside, not on the inside. Ignore what goes on the inside. So on the outside, we're going to have this little guy here and the same thing here. Sorry, my bad. And another little thing going on here. We're going to have the same thing on this side. All right. And the same thing here. All right. Then you're going to have the curved portion here going all around. All right. And they're going to have this front piece. You're going to have the back piece. All right. And then you're also going to have the top. So you have to really think about it carefully. All right. So we want the top. Let me see if I can scroll down. So we're going to need the top, 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 top. Sorry, my bad. So top. So, my bad. So top of, I think somebody said it was a cuboid. So I'm going to use the word cuboid. Top of cuboid plus around the cuboid, around the cuboid. How you spell boid? B-O-I-D. All right. And we're also going to add plus curved cylinder, C-Y-L-I-N-D-E-R. Something along that line should take us home. Let me go back to the diagram because we have to make sure we know exactly what we are. So it's the top plus going all around here, the top plus all around, plus we're going to need this curve thing going on here, all right? The curve thing here, this curve thing going on around here. So let's deal with the top first. When I say the top, I'm talking about the top, which is going to be 4 times 12. Nice. So let me see if I can go to the next page. So it's going to be, I'm just allowing you guys to agree with me. 4 times 12. Keep that. Then we're going to add plus.
You understand the writing, sir?
You can't read my handwriting?
No, sir.
My bad, man. And I look like 4 times 12 to me. You know, see 4 times 12 on the screen. Jaden.
Yes, sir. Yes, sir.
Yeah, man, it's 4 times 12, man. It look like it's the equal sign that look messy. This sign here look weird, not true. That should be equal sign, all right?
All
It's
right.
equal, my bad. Equal. All right, so 4 times 12, that's the top. And then we're trying to go right around, all right? All right, Jaden. So we're gonna go
Yes.
all around now. So now we have another rectangle going on right here. All right, so this is going to be 12 times 4. 12 times 4. No tricks. 12 times 4. 12 times 4. 12. I'm seeing 12 times 4. Oops, my bad. 12 times 4. That's what I'm seeing as well. And then that's 12 times 4. And we have another 12 times 4 at the back. We have another 12 times 4 at the back. If you agree with me, that's fine, you know. So we're going to multiply this guy by 2 just to make sure. And then we're going to have, so this is the top. Well, let me go back again. So this is the top. All right. And this is the front rectangle, back rectangle. And then we're going to look at the end now. So this is going to be the end now here, the end here. And this looks to me like it's going to be 4 times whatever this length is. And it's 4 times 4. Hello? 4 times 4.
Yes, sir.
Nice. 4 times 4. Take your time. We'll get our marks. It's a lot of marks, so we get our marks. So it's going to be 4 times 4. And we're going to do that twice, okay? Because the same thing that is here is going to be down here. So that takes care of the top, the front rectangle, back rectangle, and we also have these two little rectangles here. In fact, they are squares. And that takes care of the top part. Now, the next thing we're going to do is to add it now to the surface area of the cylinder. Now, the surface area of the cylinder is going to be the curved length. We spoke about that before. Is the curved length, same curved length here, same curved length down here. So it's going to be the curved length, all right, times the length. And that will give you the curved surface area. All right. That's this piece, by the way, if I can find it. I don't even know where it is. I think it's going to be this piece. So it's going to be a half of 2 pi r. So where are we? So we're going to do now. So we're going to have now plus a half of 2 pi r. Now a half of 2 pi r is going to give you that semicircular length. And then we're going to multiply this now by the length of the cylinder, all right? And then we're going to add it now to the 2 semicircle. Now, if I have a semicircle and I add another semicircle, that's the same thing as pi r squared. Let me go again. Semicircle plus a semicircle area is going to give me pi r squared. So this, my friends, is going to give me the surface area for the cylindrical part, okay? This is the curved portion, and these are the ends, all right? So the two ends, pi r squared, half of pi r squared plus a half of pi r squared will give me a full pi r squared. Any questions? Do we agree?
Yes, sir.
Yes,
All
sir.
right. All right, beautiful. So this we can work out up here, and then we're gonna add this what we got up here plus. Let's put in numbers now. So plus we're gonna have a half of 2 times pi times r, which I don't remember what r is. I have no idea what r is. R here is going to be, you have to be careful here, guys. This is the diameter.
R2. R is
This is
2.
diameter. So it's 2. Nice. Very good job, somebody who said 2. Times 2 times, we still have more work to do, times the length, and the length is going to be from here to here, okay? Which is this length here, which is 12.
12.
Nice, very good job. 12. So this is times 12. What a lot of numbers. All right. Plus pi 22 over 7 times r squared, which is going to be 2 squared. I think I collect everything, You know, if you add this to this, you should get the right answer. So this is going to give me equal to, did anybody work out the top part for me? I'm sure somebody would have worked this out for me already. 48 plus, somebody working. What you got for the top part?
Oh, sir, 48 plus 96
Mm-hmm.
and
Plus 32,
Mm-hmm.
176 in all.
176 plus, now we need to add this piece now. All right, and that should give us the answer, and that will give you your 4 marks, okay?
okay, sir.
So it's a half of pi r, 2 pi r, which is the 7 times the length, half of 2 pi r times the length. Yes, beautiful. Mm-hmm. Nice, nice, nice. So we just add this to this, and we should get our response. Nice, nice, nice. And that is going to give you the total surface area. Shanna Lee, you working it out? Do. Anybody working this out? This is just this times this times this plus this times this. Shouldn't be too hard to work out. Anybody? Any answer? I'm beginning to wonder if you guys are hearing me.
Sir, I got 194.855
For this piece,
when I
this
add
plus
everything
this?
together.
This plus this?
No, I added with the 176
No,
as
I want the other
well.
part though. Since I had the 176 already, I wanted to just get this plus this.
Oh, okay.
So this is the top piece and this is the bottom piece, okay? Top piece, bottom piece. And what's the total you got? Do. 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 Anybody from the chat who mentioned what this is?
I'm seeing 12.57 in the chat.
12 point?
57 in the chat.
Okay, good. So this will be 180. I'm doing this in my head, so don't castigate me.
Excuse me, sir, 1 minute.
188.57 cm squared. Yes, Mariana?
For the 12.57, can you repeat where we should calculate again?
We're trying to work out what this is.
Oh,
Plus
1
this.
minute,
Plus
sir.
this. Plus.
Okay,
This
sir.
plus this. This is the curved part without the end. All right, this is the end part. All right, so this is the end of the cylinder, and this is the curved part of the cylinder. I don't know if this is correct, but I'm hoping it is correct. This plus this give me 12 points.
Sir, for the part where you have 2 pi r, I got 6.285. And the other part where you have pi r square, I got 12.57. And when you add that together,
Oh,
I
so
got
pieces missing then.
18.855.
What you got in all? What? How much you got here?
I got 18.855.
18 point. Somebody's internet is bad. Is it my internet is bad? I'm not hearing you.
I'm not hearing her either. I think it was Mariana. Was it you? I'm not sure if it was Mariana. Oh no, it's Rihanna.
Sir, you hearing me?
Yeah, but you're cracking up a little, Rihanna. Go ahead.
Sir, for the part where you have a half 2 pi r, I got 6.285 for that part. And then for the part where you have pi r square, I got 12.57. And when you add those together, I got 18.855. I think that's for the bottom piece you were asking about.
Yeah. This is fine. So now we're gonna need to add this to 18 point. Yes. 18.8 whatever. So
Sir, now you need to add the 176 to the 18.855.
correct. Beautiful. Excellent. All right. So again, don't lose sight of it. We're just basically taking the different parts. All right. That's the top. All of this is the top, which is 176, and this is for the bottom portion, which is the curved portion plus, all right, the ends. So this is the two ends, okay? It's a half of pi r squared plus a half of pi r squared, which is just pi r squared, okay? And we got 18.85 to add. Nice. Let me go back and see my diagram just to make sure that we are on the same wavelength in terms of what we just did. If I can find my, okay, let me see if I can find the mouse. All right, so that's it. Okay. 4, 2. So that's area here plus area here, pi r squared, half of pi r squared plus a half of pi r squared. So this is this part plus this part that gives me pi r squared, and then the arc length times the length here, right, which is what we did. So it makes a lot of sense to me. The volume of the solid. That's not what we just worked out. We just worked out the curved surface area. All right. All right. So everybody okay with the calculation in terms of what we did? Look at the diagram again. Well, we have to basically, there's no formula for this, all right? Just remember, guys, there's no formula here. You have to just basically take it into bits and pieces, all right? The top, the front, the back, and the two sides on top. And then we look at this surface area here with this surface area here, along with the curved surface area going all the way, all right? And that's how we did it. Makes a lot of sense to me. All right. So that was part A. And it was 4 marks, guys, so don't feel too bad. It's a lot of work, but it was 4 marks. Part B. Could somebody read part B for me? Calculate.
Calculate the volume of the solid.
Awesome. So what we can look at now, Rihanna, is if you look at the figure, if you look at it from the front, let's call this the front. If you look at it from the front here, all right, if you look at this area here, you have to agree it's the same as this area over here. Over here, if I can find my pen. All right, and because of that, guys, we say that this figure is regular. So one simple way of finding the volume is to use what is called the base area, which in this case it's this area times the height. Okay, that's how we go about it. So it's base area times the height or the length in this case. It doesn't really matter if you use height or length. So the question, what is the base area? Now the base area consists of this along with this semicircle. All right. So base area is now going to be, you just need to look at one base area. You don't need both. One base area. So it's going to be 4 times 4. 4 times 4 plus a half of a complete area of a circle. So it's going to be plus a half of pi r squared. So it's going to be 4 times 4 plus a half of pi, over 7. This is 22 over 7, guys. Forget about the handwriting. Times r, we said r was 2, times 2 squared. Why is that my thing not writing properly? 2 squared. Now this, my friends, is the base area. Now what I want you to do is to work out what the base area is. Because once we find the base area, the volume is going to be very, very easy to find. Hello? Are you guys okay with the base area calculation? Anybody?
Yes,
Can just
sir,
say
we're
yes or
hearing
say
you.
so you guys are okay with the base area calculation? The rectangle up here, which is also a square, plus a half of the complete circle. All right, I think Mariana is saying yes, which I'm happy to see. All right, so could somebody tell me what this number is? Once we get the base area, we're almost there, guys, trust me. Once we get the base area, almost there. Anybody have a number for the base area? 4 times 4 plus a half of 22 over 7 times 4. All right, and I'm waiting for an answer so that we can use the base area, because the key, guys, they must always remember that volume, if it's regular, it has
Sir,
to be
I
regular,
got
is base area. I soon come to
okay.
you, Rihanna. Base area, all right, times, I think the formula is 8 times height, whatever height means, height or length, it doesn't really matter. Height. So in this case, the base area is, what did you get?
Sir, I got 22.2857.
22 point?
2857.
2, 8.
Sir, let's put 2.22.3.
22.3. Nice. So that's the base area. So the volume now, guys, is just going to be the base area, which is 22.3. 22.3. And we're just going to multiply this now, my friends, by just the height, which is from here to here, okay? So it's from here to here, and from here to here looks like 12. See? 12. And that's the answer. Not so bad. All right, and that's your answer. 22.286 times 12. Anybody, any answers? 22.286 times 12. 22.286 times 12. It's about
I got 267.432.
267.
0.432.
0.432. Okay. Awesome. And because it is volume, it's going to be cm times cm times cm, which is
Centimeter cubed.
cube. Okay. Nice. All right. And that's it. So volume, guys, the take-home message here is that the volume, if it's regular, it's always going to be base area times height. Now, we didn't have a formula for base area, but we were able to compute the base area. All right. We have a little rectangle going on up here. Actually, this rectangle is a square. So we have this little rectangle up here, which is a square, along with this half of a circle. All right. And with that, we were able to compute the area of the base. Now, once we have the area of the base, the volume becomes very, very straightforward. And that formula works every time, guys. Doesn't matter what it is, call it the volume of a prism, okay? So that's it. All right. Any questions? If there are no questions, we're going to move on to the next slide. I think the question is not finished as yet. So let's go on. No questions. All right. So all right, so we got volume to be equal to 267 point. All right, cool. Now, Rihanna, if you're still here, you want to read for me? The solid.
The solid is made from gold. 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is 42.62. Calculate the gold used to make the solid.
All right, so maybe these numbers just like you read it like that and it might what the hell is going on. But what we really want ultimately, as you can agree, we're going to want to find what is, oops, let me see if I can find what we're going to want to find for sure. We're going to need to find what is the cost of 1 cm cube. Oops. Oh gosh. Cm cube of gold. Sorry guys, my pen is not cooperating enough. GOLD of gold. Now, going back to the question, it says that 1 cm cube of gold has a mass of, now the cost is in terms of mass. So now we have 19.3 grams. 19.3 grams. So it's 19.3 grams times. And then the question also tell you how much it is per gram. 1 gram is 42.62. So it's 42.62. Now this, all right, so 1 cm cube weighs 19.3 grams, and each gram costs $42.62. And so the cost of 1 cm cube of gold is going to be this times this. And if you work this out, you're going to get a dollar amount, all right? Anybody get a dollar amount? 19.3 times 42.62. And that's going to give you the cost of 1 cm cube. So 1 cm cube is going to cost, oh gosh, my handwriting is gone to the dogs. It's going to cost, what do you have here, guys?
Sir, I got 822.566.
822.56. Beautiful. So this is going to be 822.56. Now the question is now, is how much the entire thing is going to cost, and that's going to be our big unknown. Now the volume, we did work it out before. Don't remember we did work it out before. The volume was 267.43. See it here, guys? The volume was 267.43. 267.43. Look at this. We're getting very, very good. Oops, my bad. Handwriting is I forgot, 267.43. All right. And this is the unknown now. Our job now is just to find x. We can always draw a line, and cross multiply. Now, 1 times x is x. And if you cross multiply this times this will give you your final answer, okay? 267.43. You can use a calculator to multiply this times 822.56. And this is going to be your final answer, guys. And this is going to give you the full amount that it costs for the gold. All right. 1 cm cube costs 822. The question is, how much does 267.43 cost? You could just multiply.
$419,777.22.
419,000?
219.
Oh, my bad. 219?
977.
977.
0.22.
0.22. All right. So that's the cost of
0.22. 22,
yeah,
not 10.
yeah, I know it's 22. I just put 20. I just round it up. Yeah.
Okay.
Yeah. So that's it. So question should make a lot of sense. If you dissect it that way again, you were just given this weird figure. You had to make sense out of it. Weird figure, they ask you for the surface area first, and then they ask you for the volume. All right. For the surface area, you had to take it apart. But for the volume, it wasn't so bad because we realized that the area on this side, all right, is the same as the area on this side. All right. Both ends. Once the area on both ends are the same, you can think of it as a regular figure. And once you have a regular figure, the volume is always going to be base area times height. So we found the volume, and then we're asked to do some calculation based on the volume. And the calculation there was based on the fact that it was made of gold. So we wanted to find what the cost of 1 cm cube of gold was. Once we found what one was, then we'll be able to multiply the total cost based on the total volume of the figure. All right. Any questions, guys? Hello, we're making good progress. Any questions?
No, sir.
We're good. We're good. Good. All right. So let me see. All right. Ooh, this is a lot of fancy stuff. All right. So we have one more questions, guys, before we're gonna spend our time on one more question, and then we'll send you home, guys. All right. So make sure you get some time to appreciate everything that we have done. So we're gonna start from here. Oops. As usual, remember, you need to look, and the first question to ask yourself is, what am I seeing? Now, I'm just looking here. It looks to me like I have this me personally, looks to me like there's some liquid or some kind of stuff inside of this cylindrical. This is not cylindrical. What do you call this container again? This cuboid looking container. That's what I'm seeing. Anybody else? What are you guys seeing? Hello? You need to tell me what you're seeing, guys, because what you see is exactly what it is. And we're going to work based on that. Hello? Somebody? What are you seeing? Anybody? Yes, Ray J? Ray J, I think you broke up. Your microphone went. Anybody else?
Sir, it's two rectangular cuboids.
See, this guy is seeing two rectangular cuboids, which is awesome. You know, I didn't even look at it that way, but you're absolutely correct. If you see two rectangular cuboids, you're correct. I agree with you totally. All right. Anybody else? What you see? Because we have to see.
I'm seeing a tank with water.
You see tank with water. Well, if this is tank with water, that's fine. All right. That's beautiful. Beautiful. All right. Somebody see a swimming pool with some water in it. That's correct as well. Anything you see is going to be correct, and we're going to be working with that. Now we are going to read and see what the question says, but almost always it's going to, whatever you see is going to be correct. The diagram, you can read for me, Shanali. I know you have a very nice reading voice.
The diagram below shows a rectangle tank with base 40 cm by 50 cm that is used to store water. The tank is filled with water to a depth of 15 cm.
Which is what we are seeing, right? Hello?
Yes, sir. Yes, sir.
40, 50, and this is the
And
depth.
15.
Beautiful. Which is what I think was KJ who said he saw two cuboids. So this was the cuboid, that one of the cuboid that Ray J saw, the shaded one, which is good. All right. Read for me again. Oops. Yes. Read for me.
Calculate the volume of water in the tank.
All right. So in that case, we can use, ta-da, always my favorite formula, base area times height. I love that formula because it works every time. Once a figure is regular, the area at the bottom of the tank is the same as the area at the top of the tank, and that makes it regular. So volume is equal to...
Sorry, sorry, if we got time left, we can probably try an irregular shape.
No, we're not gonna get an irregular shape, because if we get irregular shape, it's all sort of stuff can happen. All right. So irregular shape, you have to just take them piece by piece. It's Ray J speaking. Yes. If
Yes,
it's
sir.
irregular, Ray J, you have to take them piece by piece by piece. So it's a case by case scenario.
All right,
All right.
okay.
So you would
Yes, sir.
not be able to deal with it as a formula per se. All right. You'd have to just look at it and just deal with it. Yeah. So good
All right,
question.
okay, sir.
Good question though. I like that question a lot. Yeah. All right. So in this case, it's base area times height. So in this case, we can take the base area to be 40 times 50. That works. We could take it to be 40 times 50, and then the height is going to be 15. And this is your final answer. You get the 2 marks, and you smile and move to the next question. Well, to the next part. That's it, guys. It's 2 marks, but we get 50. We get 2 marks for it, which is good. Okay, you have to reason it out. All right. So not only you have to reason it out, but you have to make sure you get the calculation correct. And don't make any mistake with the calculator, guys. You don't want to waste marks. You don't want to give away marks. So take your time and make sure you get the right answer. Is it I'm getting 35,000, but I'm not sure if I'm right. For me, it's 3,500. Somebody? That's what I get in my
Sir,
head.
30,000.
Only 30?
Yes, sir.
30,000.
30,000? What? That's correct? All right. All right. And in this case, the unit is going to be cm times
Cube.
cm times cm, and that gives us cm cube. Good, good, good. All right. So no tricks so far. So we're gonna move on. 30 already 30,000, which is good. All right. So we're gonna move on. And there's a part B. All right, part B. Tell me what you guys see in part B. You have to tell me what you see first, all right? Because whatever you see is almost always going to be correct. What do you see? Somebody, anybody? What do you see?
Cylinder, sir.
Well, cylinder, sir.
All right, a cylindrical tank, and it look like it's all full, or maybe have something in it, right? Something like that. Very good. All right, so now we're going to start reading now, just to confirm that what we see is what we see. All right, so the cylindrical container shown. Somebody's going to read for me because I can't read. Who's going to read for me?
Bijane, are you going to read, seeing that your mic is open? Bijane?
Okay. The cylindrical container shown below is used to fetch more water to fill the rectangular tank. The container, which is completely filled with water, has a radius of 20 centimeter and a height of 21 centimeter.
Beautiful.
All the water in the container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank.
Okay, that shouldn't be too hard. So what we can now do, it seems to me like we can just find the volume of water that is here and add it to whatever we had already, and that's it. 3 marks. So this is a nice 3 marks. So the question is, what is the volume of water in this tank? Now,
So,
go ahead, Reggie.
sir, if we find the area circle first, if we define the volume, so you're gonna put pi r squared. Yeah, follow along r.
You're absolutely correct, man. You're correct. I love the way you're thinking, because that's exactly how I would be thinking as well. I love that, Reggie. So we're going to find the base area, because this area is the same as this area up here. It makes the figure regular. So volume, you don't need to go around and carry a lot of formula around in your head. It's always going to be base area times height. And in this case, the base area is, as Reggie just said, it's going to be pi r squared, okay? So it's going to be pi r squared. That's the base area. And the height, obviously, is 21. So that's not so bad. And that's it. That's the volume, all right? volume. Volume equals. Now, take your time, guys, and make sure you don't make any mistake. Pi r squared, that's the base area. Then you multiply by the 21, and that gives you the volume of the cylinder, which is the volume of water. Now, this is going to be added to whatever is already in the tank, okay? Any
Sure,
numbers?
so I got 1,256.8. Sir, I used the 3.142 instead of the 22/7. So I
All right,
got
I think
1,256.8.
0.8.
Yes, sir.
Yeah, man, we work with anything, man. Anything you get, you'll get the full marks anyway.
Times the height, which is 21.
Whoa, man, you confused me now. So you're
What?
saying the
What
final
is?
answer is not this?
Oh, no,
Sir, the
sir.
final answer would be 26,400.
Sir, I was
20,
working along. Okay, my bad.
26,000?
400.
400?
Yes, sir.
Oh, that's a big number. All right. All right. So this is going to be volume of water. So it's going to be Cm times Cm times Cm, which is Cm cubed. So now we're going to dump this water into the tank. Now, because we're dumping into the tank, we're going to have the new volume. Whoops. New volume is equal to the old volume plus water added. Sorry, water added. Okay, ADDED. Now this is going to be, we just worked this out to be 26,000. Can somebody remind what the number is?
Yes, sir.
26,400.
26,400.
400. And we had some
And
before,
it's
right?
being added to 30,000, I believe.
30,000.
30. Look at that. Beautiful. All right.
The
And that looks to me
final
like,
answer is 56,400.
right. All right. Good. And this is Cm times Cm times Cm. Check. We get off marks. Nice marks. And we move on. That's it. At least that's what I think the question is asking us. It says, calculate the total volume of water that is now in the tank, all right? So it's what was there before plus what we added. And when we dump it together, we get 56,400. Hello? Everybody happy? You can feel good, you know?
Yes, sir.
Nice.
Yes, sir.
Beautiful. All right. And then we still know that there are other parts of the question. So let's just move on to the next part. And hopefully we'll be able to get some more marks. Because we're getting marks so far, you know. So far we're going 2 and we take the 3. That's 5 marks. And then we're going to say part C now. Read that for me now, guys. Somebody, Shanley, or I know we have some very good readers.
Sure.
Dejanay
Sir,
was a good reader as well. We have some good readers in the room.
So read it.
Yeah, man.
Show that the new depth of water in the rectangle tank is 28.2 centimeter.
All right. You know what we can do for this one, Channel, who read that a while ago? Channel. We
Yes,
can
sir.
just remember the same formula for volume is base area times height. You see how important that formula is? Base
Yes, sir.
area times height. So what we have is 56,000, I don't remember what the number is. Sorry, guys. I think it's 400. All right.
Yes, sir.
Equals base area. Look at that. Times height. Now the base area here is 40 times 50. Look at that. 40 times 50. And then we're going to multiply this guy by the h, the new height. So the new height, guys, can say therefore h is now going to be equal to, look at that, 56 4 400. And then we're going to divide by 40 times 50.
2,000.
40 times 50. Sorry, guys, I
Oh,
screwed up a while ago. So I'm going to put 50 times 40. It's the same thing, 40 times 50. I just wrote the 50 first because I made a mistake. So I call it 50 times 40. And that is going to be our new height. The question says it should be close to 28.2. That's what the question is ready to show. All right, so hopefully
yes,
we
sir.
get this. What do we get?
28.2, that is the
28.2.
answer.
Look at that, 28.2 cm. Oh, look at that. You see, we're making good progress, guys. 0.2 cm. Okay. So again, don't overthink the problem, guys. Just look at what is presented and what is being asked. We have the volume, guys. So they have a new volume up here, all right? All right. New volume. All right. So it goes, when you dump in that water, you get somewhere, it raises, all right? So we have a new volume, which we just worked out to be 56 point something. So the question is, what is the new height? And this is what we call H. And this H turns out to be 28.2. Ta-da! Make sense? I need to hear a yes, sir, or yes, Sam. I need to hear oh, Shanley says it's thumbs up. All right. I need more than Shanley. Do I need somebody to say something like, yes, this makes sense?
Yes, sir. Makes sense.
Beautiful KJ. All right. So KJ is with us and Shanley is with us and everybody seems to be happy. So now we're going to see if there's more to the question. I'm not even sure if there's more to the question, but we're going to scroll down to see if there's more. And if there's more, guys. And because there's more, we're going to do more. Now, there is more. Shanley, your time, Shanley,
Yes,
to read.
sir.
To read.
The vertical height of the rectangular tank is 48 centimeter. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled.
Oh, gosh. That's a wicked question, you know. I think this question is hard. I really think it is hard. All right. So what we need to find out is, my guess is that we need to find out how much empty space is above. All right. And we need to fill that empty space with water based on the cylindrical tank. So I think I know how to do it. But you have to really, it's only 2 marks, guys. And sometimes 2 marks is either easy or hard. And in this case, this 2 marks is not an easy 2 marks. At least I don't think there's an easy 2 marks here. So what I'm thinking, guys, this is where I am thinking, all right? I may be wrong, but this is the way I'm thinking, all right? So this is maybe the best way to think about it in my view. So oh, no, tank is the word. Sorry, wrong word. Remember, I can't erase Kami because I don't know how to use this thing so well. So I'm gonna say one cylinder, cylinder, one cylinder, raise the height from 15 to 22. So don't move. Work with me, guys. I'm trying to find it raised it from 15 to 22, 28. So it raised it to a height of so one tank raised it to from 15 to 28.2. So it raised it to, is it 13.2? I'm guessing it's 13.2. So I'm going to write 13.2 here. All right, give me a 13.2 cm. All right, check. Now, the question is now, how many cylinders are going to be required for the empty space? EMPTY, empty space. All right. Now the empty space here is going to be 48 minus 28.2. So the empty space here is going to be, could somebody write this out for me, guys, just to see what the empty space is? So you see, we're kind of breaking down the problem nicely. We're breaking down the problem nicely, guys. We say, hey, one cylinder will raise the height by 13.2 cm. So the question is now, how many cylinders will be required to fill the empty space?
Sir,
Yes, where are you? Yeah,
19.8.
19.8. All right, cm. Now, everyone will jump it by this, all right? So obviously you're going to need more than one, all right? But it seems that you're going to need less than two. That's my answer. That's what I'm thinking. One will raise it by 13.2. So how many? Let me read the question again, just to make sure that I'm answering the right question. Let me just read D. Could you read this for me again? Determine, guys. Somebody read for me. Determine. Determine.
Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled.
Right. It seems like it's going to be, thanks, Shanely. I think what the answer is going to be, looking at my numbers, it seems to me like it's going to be more than one, but less than two. All right. But we can work it out. So one is going to take care of 13.2 cm in height. So the question is, how many will take care of the empty space, which is 19.8? Because this is what is left to be filled. All right. Hello? Could somebody give me an amen?
Amen.
All right. And then we can
Amen.
actually cross multiply, guys, and we get x, because x is what we're looking for. In this case, x is going to be, we're going to get 13.2 times x equal to 19.8. And so x is going to be 19.8 divided by 13.2. And this is going to give me 1 point something. And that's the answer, guys. 1 point something.
I got 1.5.
1.5.
0.5, sir.
1.5. All right. So the answer really is 1.5. If you say 2, I don't know. I think you may get the full marks if you say 2. But I think 1.5 is the exact answer. Okay. Where is it? Let me see the question again. It says determine how many more cylindrical containers. 1.5 is good. I don't think you would lose the marks if you say 2, because 2 would make sure, 2 would definitely take care of it. But you don't want to go to 3. You're talking about number of containers. So I think 1.5 would work, would give it the 2 marks, and that's correct. But if you say 2 with the calculation, of course, you'd have to show the calculation though. So you get 1.5 here. But if you say 2 containers or 2 cylinders, that would work as well. All right. But the exact answer would be 1.5. All right, guys, I had so much fun with you. I really enjoyed the interaction with you guys. Sean and Lee, I can't even go down the list, guys. Let me see if I can stop sharing so that I can actually go through on the list and look at you guys by name. Sorry, I'm talking to myself. I'm going to look at the participants
I can
list.
squeeze in one more question.
Yes,
Try
man. Of
squeezing them
course.
up with them.
Yes. No, but the thing about it, sorry, Reggie. It's 7:30, Reggie. We have to stop at some point. So if you have a question, we can but this is really what we came prepared for. The rest of the work is for you to continue to do. If you have a question and you want to share it with me, you can always share it with Mrs. Johnson Burrell, and we'll be happy to look at that in the background. But for this particular session, we'd prefer if we stop here so that we don't complicate things, meaning we keep it as simple as we can, which in this case was just to go through these problems. So but if you have another problem and you want to want us to look at it, you can always, reach out to Mrs. Johnson Burrell, and then
All right, okay, sir.
yeah, man, I understand. Yeah, man. All right. So, just continue to practice and use the ideas that we discussed here today. The main idea for me here is just to look, guys, at what is given, and whatever you see, almost always, and that is the guiding principle, guys. Whatever you see, almost always is correct. All right. And you just work with it. Piece of a circle, part of a circle, part of an area. Volume. Remember, volume, guys, always going to be base area times height if the figure is regular. All right. Don't try to remember too much formula. If you look at this, for example, this area that was given, this formula that was given here, this is surface area. It's literally nothing more than not base area in this case, base circumference times height. Okay, base circumference times height. So if we're talking about area, it's base circumference times height. Talking about volume, it's going to be base area times height. All right. Those are good formulas for you to remember. All right. Some of the formulas are given on the question paper. Look at them, and don't give up on these questions, guys. The bad news is that this question or these questions tend to be the worst answered questions in the CSEC exam. You knew that, Kami? That these were the worst answered
Yes,
questions. Literally
yes,
the
I
worst.
knew. So even though some of these are January past paper questions, I do know that students struggle with these type of questions, surface area, volume,
Yes.
as long as it deals with measurement. We have
Yes.
a huge challenge with
Correct.
these type of questions on CSEC.
Correct. Absolutely correct. All right. So if you guys were here today, you have an advantage, guys. Trust me. Because a lot of persons, they don't even bother read these questions. They just move on to the next question. And clearly, you guys were engaged today, for which I'm very, very pleased. I wish I could say thank you to everybody. I can try, and I'm going to try actually. Alia, Annalie, Celine, Chrisanne, Damar, my bad if I screw up your name, don't worry too much about it. Dejane, Dani, Janil, Kemar, Karish, KJ, Lauren. Awesome, guys. I'm really, really happy with your presence here. Mariana, Melissa, Michaelia, Octavia, I'm seeing Rajay, Rahiki or Rahiku, Rahiki, we're gonna call it Rahiki, Rayan, Rihanna, um, you know, this name is giving me trouble. The first name for Dunkley, I think is Riyadh, not too sure. I may have screwed that one up. Ramal, you know, Shanna Lee, Sheldine, and Zoom user. Yeah, so Zoom user is also here. Guys, honestly, I had fun with you. I wish you all the best. Kami, thank you for
And
inviting.
students,
Thank
as
you.
usual, Dr. Sam is here with us for the first. So as usual, we're going to give Sir some thumbs up, some hearts, just to let him know. And you can also open your mic to say thanks to Sir
Look at that.
for
I'm seeing a
really
lot of them
being
popping up.
here.
Thank you, sir.
Oh,
Yes,
look at
great.
that. You guys are awesome, man. Awesome, awesome, awesome. It's a
And we really
pleasure.
want to thank the University of West Indies Faculty of Science and Technology, specifically the Department of Math, which is led by Dr. Maesha. They would have come on board to collaborate with the Ministry of Education, Skills, Youth and Information Region 7 with this initiative. We started on April 21, 2026, sorry, and tonight, May 7, is our final night. We wish you all the very best, students. If you missed a session, please just go to our YouTube page and you will have all the sessions there that you can look at. We started looking at trigonometry and geometry. Then we moved on to algebra, relations, function graphs. Then we switched to patterns, sequences, and series. And here we are tonight with measurement. So if you have been with us from the very beginning of our sessions, you are pretty much on your way to getting a grade 1, a grade 2, as long as you do the work. We are helping you to prepare for the exam, so you know the rest is up to you. I really want to say thanks to Dr. Sam. He filled in today for Dr. Roxanne, who could not make it. And we really want to, let's thank ourselves. Students, we're thanking you. So give yourselves some hearts, some thumbs up. You are great. And you just being here with us this evening shows that you really want to get that one. Even, who knows, one of you can be the top student for math in the CARICOM, right? In Jamaica, in CARICOM. And we really want to say thank you for being here. So all the best, students. Dr. Sam, I don't know if you want to say anything else to them before you go. But thanks, students. Thanks, Miss Anderson from Edwin Allen High. Can you open your mic, Miss Anderson, who has been here with us from the very beginning? Miss Anderson, you want to open your mic? I'm not sure if you're able to open your mic or type. Oh, your mic is open. Great, Miss Anderson. Go ahead, Miss Anderson. Not hearing you, Miss Anderson, but Miss Anderson is a teacher at the Edwin Allen High School in the best region, the best parish, Clarendon, Region 7. And she would have been here with us from the very beginning. And here she is tonight with us, the very last lap. So thank you all, students, for being here. And thank you, Dr. McDaniel, for taking us through measurement or a final CSEC math exam preparation session. I'll be closing the room soon, students, and all the best.
Before you close, Camille, just have to big up Miss Anderson for taking the time. She didn't have to be here, and she chose to be here. That's a sign of her dedication, not just to the educational system, but to her students and everybody. So thank you very much, Miss Anderson. Camille, I have to big you up, because I have seen where you are in terms of your heart, and this initiative for me is top shelf. I really appreciate and observe your dedication to your role as Region 7 coordinator or whatever the designation is. But I really
for the best subject, math,
yes,
for the best subject.
And you Kami has been doing an excellent job. I have to big you up for this, and I really hope that this translates into results, not just for Region 7 but for the country as a whole.
Yes, right across the country.
Yeah,
that's true. That's true. Thanks, Dr. McDaniel, and I'm seeing a response from Miss Anderson as well. You're welcome, Miss Anderson. And so we will close off now. It is 7:30. Students, yes. So Dr. Sam, Miss Anderson is saying thank you too as well. I'm thinking her mic, she's not able to really speak through her mic, so she would have spoken through the chat. So thanks everyone for being here with us this evening, and all the best. Take care, students, take care, teachers, and take care, Dr. McDaniel.
Thanks, Camille. Bye, everybody. Bye, my favorite students. My new favorite
Bye,
student.
sir.
Bye,
Bye,
sir.
sir.
Bye,
Bye,
everybody.
sir.
Bye,
Bye.
sir.
Bye,
Was
sir.
Bye,
was
sir.
fun. Was
Again,
fun.
sir.
Awesome. Yeah, you guys are awesome. Yes.